We have about 30 minutes of closing. I'd like to begin with the Hackfest Awards from Quinn. Quinn?
Hello. Can everybody hear me okay?
Yes, we can hear you.
Yes. Okay, good. New AirPods. I don't know if they're totally working. All right. So, wow, nothing like a presentation tangentially related to Bitcoin to find out where everyone's political inclinations lie in a chat room. So moving right along, I had the honor and privilege of leading the judging of Hackfest once again this year, and I was able to browbeat my fellow judges into helping me with that. They were in no particular order: Carrington Vanston, Kay Savitz, the mysterious 4 a.m., and myself. So everyone has submitted their entries in the Hackfest Discord there, and we have the winners. So I am just going to dive right into it and announce them in order. So the, I guess it's more fun to go in reverse order, so I'll do that. Now, actually, before I do that, the prizes, I think, this year were, people are going to choose them. Is that right?
Yes, we'll contact the winners after so they can pick their prizes. Okay,
cool. So if I announce your name in this list, you are getting a prize, and I guess you can talk to the committee to figure that out. They will reach out to you. Okay, so in fifth place, we have Ben Smith, who did a low-res Etch-a-Sketch. And this was written in BASIC, and it's a very tight little program. It was very compact and straightforward, which I think is what the judges liked the most about it. And it has some sound effects, which is not that easy to do in BASIC. So thank you, Ben. That was a delightful little project. There is videos, and everything is all in the Hackfest Discord there as well. So lots of people posted their source code and disk images and stuff if you want to check all that out. Moving right along, in fourth place, we have Micah Cohen, who made a project called Fnord, and it is a series of very low-level input filters for the Apple II. So you can prank your fellow Apple II coworkers with a filter that alternates all of your text in upper and lower case, and many others, my favorite being the one that converted all of your text into leet speak, replacing all of your T's with sevens and other such juvenile shenanigans. That was quite glorious. And that video is worth watching just because it gets funnier as you go along. I think it was well edited.
All right, this is my second video on the Fnord project. This one is just a redo intended to be much shorter than the other one, which goes into more detail and shows kind of some corner cases. And I was concerned it might be a little bit too long for a submission for KansasFest, Hackfest 2020, in which you create hardware or software hacks that are related to the Apple II. So this is my submission, Fnord, and I'm just going to showcase it without too much discussion. There will be links to the project and where you can get a copy of this disk image and that sort of thing in the description. All right, and I'm not going to waste time letting you read this. I'm just going to get right into it. there's a number. The point of this project is to sort of hook and hack the output of characters to the display. So by running these various things, and of course the hello file at the top is a basic program, and that's not one of the filters. But all the other files here are filters, and you run them with the command brun. This is a Apple DOS disk, so no dash command. Brun. Let's try mix case. And I'm just going to run the informational message that appeared at the start. So you can see that it just alternates the case of the letters as they're displayed. And this applies just as well when you are typing. Although notice that the case of the output doesn't match the case of the input. That's because the input is actually exactly as I typed it and not as it appears on the screen. This is just an output manipulating series of functions. You can type PR #0 to restore sanity, or you can also hold Control and press Reset to warm boot basic, and that'll do the same thing as far as the output is concerned. Okay, let's see what else we've got. We've got mix case. Let's try Fnord, and Fnord intercepts the carriage returns, and every time you type a carriage return or one appears in program output, then you'll see a lowercase Fnord at the end of the output. Okay. And of course, here's more Fnords. I'm going to run HL spaces, which is a very simple filter. And I'll just run the output again, and you can see exactly what it does. And of course, when you run something like list, it does the same thing there too. All of these work with that. Let's see. We've got HL spaces. How about double? And you can see this doubles all the characters. If they're letters, then it alternates upper and lower case. It does not double the carriage returns so that it doesn't add extra space between lines. It's already doing that by stretching them out horizontally. And yeah, you can type, this nonsense here, and it's going to work, sort of. Because again, the input isn't actually the same thing as what's showing on the screen. I typed a normal print command. It shows up as doubled, but it's fine. Control reset. And what else we have? We have Leet, which is an homage to the Hacksaw script kiddie kind of writing that was popular at some points in the late 90s and early 2000s. And finally, here. This one's one of my favorites. It adds A, B before every vowel, except for successive vowels that appear together. So, double has an AB before the O, but not before the U, and then it has another AB before the E that follows it. And this is emulating kind of a talking code, a spoken code that is sometimes used by, say, parents that don't want to be understood by their children. Although I always found it a little too awkward to really to use effectively. So there we have it. That doesn't look right. So those are my filters, and there will be a link for the disk image and for the GitHub project and all of that. And thank you for watching.
In third place, we have Sellam Abraham, who made the Mesmerizer Exerciser. If you've ever wondered what you can do with just 2 characters of text and a whole lot of really fast page flipping, this is the project for you. It was surprisingly entertaining, and it's a pretty interesting project in its own right, but then he took it one step further and crammed it into a 2-line basic program using techniques that I had to watch the video twice to fully understand. So I can very strongly recommend watching that as well if you're interested in the techniques in which you can fool the Apple II into storing its own code through the input buffer and things of that nature. You definitely want to check out Sellam's project. That was really entertaining.
Okay, this is Sellam Abraham, and here is my entry for Hackfest for KansasFest 2020. This is called the Mesmerizer Exerciser, and what this does is just allows you to basically veg out with the Apple II using screen flipping, page flipping. So what this is doing is it's flipping the pages of the screen very rapidly between a page filled with two different characters. In this case, it's one page is filled with spaces, and the other is filled with inverse spaces. And so as I'm using the arrow keys here to go back and forth, I'm getting different patterns as it's flipping between them. And here we have a freeze frame. Now I can use the up and down arrow keys to change the background character. So as you can see now, or at least the character on one of the screens. So right now the character on one of the screens is being changed. And then if I want to change the character on the other screen, I press return, and then that allows me now to change the other character. And then I can go and flip between them and find different effects that do weird things and interesting things, and there's plenty. And then of course it's poking the speaker every loop, and so it's making this annoying sound. So that's all fun and dandy and interesting and everything, but I thought, well, that's not very exciting after all. It's just page flipping. And here's the code, just to show roughly how much code it is, and I'll get into what's going on here in a second. Oops. And it goes all the way to, in this version at least, goes all the way to, it ends there at 3C9, right? So if we run this again, one last feature I should show is that this has a feature where you can print the parameters, which are stored at 6, 7, and 8, and that's the 6 has the loop, the delay between flipping, and then these are the two characters, right? So you can record the parameters and share them with your friends. Now, okay, so that's all great and everything, but it's is it a Hackfest entry worthy of much of anything? No, I say. So what I did is, let me boot into my booty here. I did something more interesting with it. So let's change our boot volume here. Now we're going to go into what I did with it, which is I turned it into a 2-line basic program. So in order to stuff all of that code into a 2-line basic program, I had to do several things. First of all, I had to cut out some code. So I cut out the part where it prints out the parameters, right? That had to go. And then I also whittled it down, took out a bunch of checking for this and that and the other thing, whittled it down to the bare minimum. And still with that, I got it almost exactly perfectly fit into 2 lines of basic code. There's I believe there's either exactly 239 characters up here, it might be 238, but there's exactly 239 characters here. And what I mean by that is when you enter a basic program line, you can only enter 239 characters that will be interpreted by the interpreter. So you can enter 240 characters, you can actually enter up to 254 or 55, I believe, but it starts beeping after 248, or at 248, but anything past 239 will be ignored. So this is exactly 239. Now what's going on here? There's a few things going on here. Okay, so the question is, how do you get 300 end up being 146 bytes into 2 lines of machine code into 2 lines of basic memory, right? Because you have to do pokes and all that stuff. Okay, well, there's been different techniques that have been invented over the years. One of them is the Shalam Method, where you basically poke a string into memory, and then you call the routine in ROM that will interpret that line as if it was entered from the keyboard, and then execute it. Well, I took that and made it even more efficient. I call this the Shalam Method. So that's a play on Lam plus my name, Sellam, combined it. So it's the Shalam Method. And so what I'm doing here is I'm setting things up so I can print right into memory, right? So that is the vector where the base address for where the next text output is going to go is stored in 40 and 41, right? Locations 40 and 41. Well, that's what home is doing. What home is doing is it's poking a 0 at 40. And why didn't I just say poke 40, 0? Well, because that takes 4 extra characters, right? So that's what two-line programming is all about, is absolute efficiency, finding different ways to do the same thing. Well, that's what I'm doing here. Then I poke 2 at 41. So what that's saying here is the base address for printing to the screen is going to be now set for location 200 hex, 512 decimal, of course, which is the keyboard buffer, right? And so all that's left to do now is I have to poke 33 of 255. That's the screen width. So what I'm telling it is basically don't carriage return. As long as this string is less than what this value is, the length of this string is less than this, then it won't carriage return, or which will cause the base address. This base address will change to something else entirely, and you won't have contiguous code in memory, so or contiguous string, which won't work. Anyway, trust me on that. You need to poke the 33 of 255 so it won't carriage return. And then so after we set the base address and do that, now we just need to print. And so now here we're printing this string of bytes here, hex code, which starts putting bytes into memory at C9, and I'll explain why in a second. And so there's our code, and ends here with this end C9 go, right? So it's going to execute the code at C9 after it puts it in. And then this call -144 is what actually will then interpret this, put it into memory, and then execute that. And so then we have a colon, which actually wasn't needed because A will act as a delimiter also, but in this case we had the luxury of putting a colon there. So what's happening here is then after that, BASIC is never going to touch this, right? So it doesn't care, and it's just straight ASCII. And so what this code is doing is it starts here, and it starts reading these characters and interpreting them back into hex, and stuffing them into 300 in memory. That's right here. No, that loads it. Anyway, so then it gets to the end here, right? And notice that there is a AD. Well, actually, just to show you that this is the start of the code, there's an A909, 8506. So that's load A, 0 page 9, location 9, store A, 0 page, location 6, etc. Right? And then over here we have an AD00. So AD is load A, absolute. So we have AD00, but we got a page break or a line break, and then we continue over here, right? So AD00C0. Well, this line break is taken care of with the code right here. So this basically says this code right here changes the starting address of where we are to continue reading, basically right here, and then it loads the Y register with where we're going to continue reading, and then jumps back to the beginning of the loop. So that's this code reading this code. It reads it all the way in. There's a 60 right there. You see that's a return subroutine. Anyway, so when I run it, it's going to put this into memory, this loader. It's going to load that loader, run that. That loader is then going to load this and run that, and then we're going to have our Mesmerizer Exerciser again. So ready? Here we go. And there it is. Now it operates a little bit differently because I noticed in the first version I wasn't I was doing my loop wrong. I was flipping the pages and then going back and doing all the keyboard checks and all that, and I realized, oh wait a minute, that's an unequal amount of delay between the page flips. So this actually does an equal delay between the page flips. It's flipping the page every other press of the key. So and then of course we can change our background character. We press return. We can change our foreground character, and we can, as you can see, we can get just really bizarre effects. The camera doesn't really. Yeah, there we go. You can really get some neat things going on. I'm changing the back one character. I'm changing another character. There's an interesting thing right there. Just set the delay really high here so we can see some flipping going on there. There you go. There's a slow motion flip, just reversed. And oops, let me change this character to something different. So anyway, so there you go. And now when I press escape, it does that. And just to show you the remnants of the code that's still in memory here. So if we go to C9, now I put it at C9 because, so first of all, the reason is B1 is where the code, the basic, the get next token code is, right? So I put my code at the very end of that. And the reason I did that is because by putting it in 0 page, I can take advantage of a couple things here that needed to do a 0 page address, like actually at the end here. It was less bytes to put it in the 0 page instead of somewhere else in memory. So that's why I put it here, because every byte counted when I was trying to stuff it into those 2 basic lines. Like literally everything converged into this perfect, everything just worked out like at multiple dimensions. I can't even begin to explain. My brain is so scrambled because I've been working on this literally for all day. So anyway, so there's this is the second stage loader. The first is the basic program. This is the second stage loader, which, yeah, as you can see, it's taking bytes from the basic. It's then converting them into a value, hex value, that's then stuffing into memory up here, and then down here there's that code that checks to see where we are, crosses the line boundary, when we skip from line 0 to line 1. That's what's going on here. And then the code for Mesmerizer Exerciser is right here in memory. And there it is, all poked in and looking beautiful, and ending actually. The old code is still in memory here. But anyway, that's it. This video is way too long. Thank you very much. Hope you enjoyed that. Bye-bye.
And in second place, we have our most recent presenter, Charles Mangin, with the flyover. And this one, I think, really impressed all of us because it starts out fairly straightforward. And as he explains the project, it gets more and more sophisticated. So it's a 3D voxel flyover in low-res graphics of a section of the Grand Canyon. And so he explains the data formats that he built to construct it, and then proceeds to explain how the rendering works. And being low-res, it can be a little hard to see what's going on. And so he explains it in great detail, and it just keeps getting more sophisticated. If you think it's only height mapping the top row, and no, actually it's rendering everything in a painter algorithm. You think, well, it's not perspective correct. Actually, it's perspective correct, and it goes on and on. So delightful video, great project. Charles is always a delight in Hackfest.
Hello, Hackfest judges. This is Charles Mangin. I'm recording my Hackfest entry for KansasFest 2020. I started with an image of a topological map of the Grand Canyon. Here's the Colorado River as it winds its way through the lovely twisty bits of the Grand Canyon. I then took that and created a sort of false color version of it in low-res Apple II colors, just a few colors, a couple of shades of green, brown, and then the two blues. I converted that to data and put it on a disk. And we will see as it loads from the disk what that looks like as it scrolls by. And this is interesting, but not as interesting as it could be. And what it could be is in 3D. So here we are looking at flying through that Grand Canyon map in 3 dimensions. So here it is in 2. And then here it is with the height applied to it. And you can see that the river valley is only rendering, say, 2 pixels tall, while the mountains are several pixels tall, and then everything in between is rendering in that way. The depth map of the river valley is this image here. And you can see that it's assigned lighter colors for the higher parts and darker colors for the lower parts. And so I took that image and the color image that I created from it and combined them using a Python script that essentially took the height and converted it into a nibble, and the color and converted it into a nibble, and then combined the 2 nibbles into a byte and scrolled through the full data that way. And so now what's happening is the the image is rendering in a 3D engine, so to speak, or algorithm, where the height data determines how many pixels tall each column renders, and the color is obviously the color, and that's coming from that same data file that was loading from the disk at the beginning. And it masks each successive layer by rendering only on the black parts of the screen. So as it renders, it will go from front to back and only render a few pixels in the back based on the height if they are taller than the pixels that are in front. And this is controlled by what's called I've just called it a perspective algorithm, I guess you could call it, where the bytes of the image are rendered depending on where they are on the screen. So when you're at the this is in reverse to how it's shown on the screen because I'm rendering it from front to back. But the front of the screen, the bits of the bytes of the image are rendered if the bit in this perspective data is a 1, and it rolls through all the bits of each line of the perspective. So it only renders these 40 pixels in the middle of this 120 pixel image for the first row, and then it skips a couple for the second row, and so on, until the very last row is 1 pixel and then 2 skips. And so if you were to fill the screen, it would go all the way across the image, and you'd be able to fill 40 pixels from 120 bytes of data. And so if you can see the structure here is such that it goes from seeing only the 40 pixels in the middle of the image all the way back to all 120 pixels, but it skips 2 out of every 3. On the height of the height map determines how tall the pixels render. So the water is generally in the black and darkest gray parts, and then up to the mountains it becomes green and darker green closer to the valleys. So there's the height map. And you can see as it scrolls through here, that the mountains come down to the valley and then back up to the mountains again. So for lack of a better name, I'm calling this project Flyover, and I'm hoping maybe by the end of KansasFest I can have some additional images to map and to fly over, and maybe I'll have some additional speed, because I wouldn't mind seeing it go in full speed here, flying through. The next step I think might even be to make it so that you can turn, sort of swipe left and right, depending, and it would do different pieces of the canyon, so you'd be able to see the left-hand side or the right-hand side and sort of swipe left and right. But that hasn't been finished yet, and I wanted to get this done so that I could make the video of it. Anyhow, thank you for your consideration, and have a lovely day.
And without further ado, these sorts of presentations are always really weird without an audience, but here we go. The winner is Matt R. with the Apple II Discord project. I think the judges all liked this one the best because of the technical interest of it. And it's also a very kind of KansasFesty sort of thing to do. It's very in the spirit of the community, and it's a lot of fun to play with. And I believe he has it set up, or he was working on setting it up, so you're going to go play with it right now. And his video is a lot of fun to watch as well. So what he's done is created an Apple II bot that runs on Discord. So you can talk back and forth to the Apple II on Discord. You can also write code. You can write BASIC in Discord, and it will run on the Apple II and send the output back. So it's an interactive Apple II bot that runs entirely through Discord. It's really cool, a lot of fun, and it's surprisingly sophisticated in the way that it works with the characters going back and forth. You can even play like Discord games on it because of the way he's written it. So very, very cool, Matt. Thank you very much for submitting that.
Hello, this is my Hackfest entry for KansasFest 2020. My project focuses on my Super Serial card, which I have hooked up to a USB to serial converter in my computer. To set up, all I've done is PR number 1 and IN number 1, which is the slot number for my card. And basically all that's doing is that's being sent to a code I wrote in JavaScript, which is using Node.js and Discord.js. And it's making essentially a Discord bot that takes input from Discord channel, sends it to the Apple II, which interprets it and sends the output back into the channel and sends it out there. So you can actually see the IN being sent to the channel right there. It's hard to do with one hand, so you have to bear with me, but I can go print hello, send that, and to print hello. Glad I implemented that, and you can see there print hello, and it prints hello and is right there on the screen, and there's the new line. The reason that happened is because I edited it so that you have to tell it to type, because type adds a new line on the end. Well, as if I want to send a single character, I can go bang A2, char for character, and we'll just send an H for Hackfest. And you can see there, it just sent an H, and in a moment we see that output. And so that is useful for games where it wants a single output without a \n. Yeah, so you can basically run BASIC through Discord. And on top of that, I actually have a thing. I have a disk in my disk drive. So if I just get rid of this line, you can actually see I also added the emoji instead of the beep noise, so you can see that there. If I type PR number 6, I have edited a master disk of Eamon to allow it to be run through my API. Basically all it's doing is adding PR number 1 and IN number 1 to the beginning of the source code. But yeah, you can see that running there. The graphic sadly doesn't send yet, but yeah, you can see the text starting to come there. And this is where the char starts to be useful. Is here we can just go to char. And I've had an issue with speed where it doesn't seem to read that quickly, but it goes fast enough that it's reasonable. And so we're gonna go to the desk, and you can see the prompt is going over there well enough, and we can go on, and you can play through the whole base beginning level and cave and stuff, and after that it exits gracefully and you can keep coding in basic. Yeah, there are some limitations. Like, I learned you can't actually send Control-C through a named pipe to the Apple II, so if you get stuck in infinite loop, you kind of have to manually turn off and on the Apple II again, which is fiddly, but you got to do what you got to do. And yeah, I really enjoyed doing this. This is my first time working in JavaScript, first time with Node, first time working with the Discord API. I learned all that fresh for this project. I also learned a lot about BASIC, because I'm still not very proficient, and I'm learning more and more about how to control my Apple II. Named pipes were new to me, and I'm now more proficient using the terminal. Hopefully I can talk to the mods of KansasFest, and we should be able to get this bot running on there too, and hopefully people can start playing with it during KansasFest. I hope you enjoy it, and have a wonderful day. Thank you.
And imagine a room full of raucous applause, because this is very weird doing this virtually. And thank you very much to all of our winners. This was a really, really tough year. I've judged quite a lot of these things now, weirdly. And some years are easy and some years are hard. This year was really, really hard. We got a lot of really fantastic entries. So thank you all very much. And Peter, I will give it back to you.
Thank you, Quinn. Thank you for your effort and the rest of the judges taking the time to work through all these entries, understand sometimes the complex things that are going on. All the entries right now are in the Hackfest channel on Discord. We will grab those and preserve those on our website for you to download and view at your leisure. Hackfest is always one of my favorite contests, so thank you. Next up, Kate, tell us about the future of KansasFest.
Okay. Can you hear me?
Yes.
Okay,
Yep.
perfect. I just want to make sure I'm on the right mic. All right. So, in wonderful news, knock on wood, that we'll all be together next summer, from July 19th to 25th to 2021 at Rockhurst University in Kansas City, Missouri. The future. And we have already secured, we know that Mr. Robert Woodhead of Surtex Software, the well-known co-creator of the Wizardry series of computer games, he will be joining us as our keynote speaker next year. Robert Woodhead, yes. So just those of you who aren't familiar, at an early age, Robert Woodhead, aka Trebor the Mad Overlord, was consumed by two passions: computer programming and not having to have a real job. He first achieved this by writing computer games for Surtex Software, notoriously co-authoring the first 4 Wizardry CRPGs, first for the Apple II, and later for other lesser computers. In 1989, deciding that this wasn't nerdy enough, he co-founded the oldest surviving anime releasing company, Animigo. Other things he's done include writing one of the first MMO books, building a 2-time national champion combat robot, serving 4 terms on the EVE Online Council of Stellar Management, and not being liquidated by his wife. Yay. Yet. I've got the script on my other screen and it's kind of far away. So join us in July of next year at actual KansasFest. We look forward to hosting as many of you as we can in Kansas City for reals. A couple other announcements. Peter, do you want me to keep going?
Go ahead.
Okay. A couple people have asked about the Discord server. Y'all are having such a good time with it. We are working on how this is going to work logistically right now. It's going to live on for a few months. We're not going to nuke it tomorrow. It'll still be here for a while. The committee is going to put our heads together when we have a few more processor cycles to spare and figure out the logistics of if and how we can keep the Discord as a thing. I'm glad everybody is, and we are glad everyone is enjoying it and using it. And obviously tonight, just like we did last night, let's all get together on the voice channels and the video channels and have a good time like we did. Those of you who are wondering, these Zoom videos that we've been taking have been recorded. And just as we have in past years, we're going to do the post-processing on them, and we're going to post them to both our YouTube channel and the Internet Archive, so keep an eye out for that in the coming months. And if you at all, before you leave the Zoom room, please help pick up your chairs, take out the trash, make sure you have all of your pens and chargers and phones or whatever, and we don't want to have to call you and say, hey, you left your phone. And thanks everybody for coming and joining us this year. This is speaking for myself, at least. This is more than I ever thought it would be, and y'all are just wonderful. I was like crying happy tears last night at how well y'all adapted as attendees and came together and enjoyed this online conference. So does anybody else on the committee want to say anything?
I'll give one last thanks to Sally for doing the captioning. Thanks again, Sally, for spending all that hours with us these last 2 days.
No, Kate, I think you said it all.
Don't forget that the Discord will no doubt be very active tonight. We do have the video chat rooms open there. So even though the sessions are over, KansasFest is not really quite over yet. Thank you. Thank you for everyone's time and expertise.
Question in the chat. The Discord's not going anywhere. I mean, it's not going anywhere for a couple of months. So you can stay up all night on Discord if you want. You get down with your bad self.
Any other comments from the committee members?
No. Well, hope to see you guys next year. Yeah.
Yep. See you next year. Hey, actually, let's thank Paul for playing all the pre-recorded videos. I think,
Paul worked
mostly
really hard. Yeah, Paul
mostly
did.
Success, yes.
Yeah. No,
That
Paul.
was
Yeah, special props to Paul. He really moved heaven and earth to get the videos to work and work properly the way they did. So that was a feat of engineering.
Definitely.
Yep. Thanks. And thank you everybody for participating. This has actually been almost a surprise how large the audience was. So I'm glad everybody got a chance to see what it's like, and hopefully we will see a large proportion of you in Kansas City next year.
We had over 500 people registered, and at any given time there were close to 300 people online.
All right.
Thank you. I'll see everyone online.
See you guys next year.
Bye-bye.
Bye. Thank you.